Ever wonder how an AI goes from just being a giant text machine to something that's actually, helpful? Well, that's exactly what we're going to break down today. We're pulling back the curtain to demystify how we train these large language models to be helpful, harmless, and honest.
So before we get to the solutions, you gotta understand the problem, right? And researchers came up with this fantastic metaphor for it. They call a raw, pre-trained AI a stochastic parrot. Think about it. It's an amazing mimic. It can string words together just like a human because it's seen billions of examples. But, and this is the huge catch, it has zero idea what any of it actually means. It's just predicting the next most likely word.
And that right there is the massive gap we need to cross. On one hand, we want this thinking machine that gets context and reasons with us. But on the other hand, what we start with is basically a super advanced version of your phone's autocomplete. It's just sorting by probability and following patterns. So the billion-dollar question is, how do you turn that pattern-matching parrot into a real, helpful partner?
All right, here's our game plan for how we're gonna solve this puzzle. First, we'll get up close with that flawed but brilliant AI brain. Then we'll cover how we teach it what humans actually like. After that, we'll talk about giving it an open book to read from. We'll even see how AIs can judge other AIs. Then we'll peek under the hood at the real secret sauce. And finally, we'll wrap up by looking at what's next.
Okay, section 1. Let's really nail down this stochastic parrot idea. That word stochastic sounds super technical, but it doesn't just mean random. All it really means is that there's a system of probabilities guiding its choices. It's not just throwing words out there. It's making a very, very educated guess based on all the data it's seen. But at the end of the day, it's still just an incredibly sophisticated pattern matcher. So if it's just a pattern matcher, how do we get it to do what we want? Well, that leads us right into our first big solution. We have to teach it. We have to show it what we think a good answer looks like. This whole process is called alignment, getting the AI to follow human values. And one of the first and most famous ways to do this is a technique called reinforcement learning from human feedback. Yeah, I know, RLHF sounds complicated, but forget the name for a second. The concept is super simple. Think of it like a taste test for the AI. Instead of writing out a massive, complicated rule book on how to be helpful, we just have humans look at two different answers from the AI and say, yep, I like that one better. It basically happens in 3 stages. Step 1, we get humans to create a huge data set of these preferences. They just sit there, looking at pairs of AI responses, and click on the better one, over and over again. Step 2, we use all that data to train a separate AI called a reward model. Its only job is to learn to predict which answer a human would prefer. It becomes our automated judge. And then, step 3, we use that reward model to train the main AI. The AI generates an answer, the reward model gives it a score, and the AI learns to generate answers that get higher and higher scores. Okay, but here's the catch. RLHF, while it's super powerful, is also a beast to implement. It's really complex, it's expensive, you're juggling multiple different models, it's just a lot. And for a while, this meant that only the huge tech companies with tons of resources could really do it well. But that's where a newer, smarter method comes in. Direct preference optimization, or DPO. DPO is, well, just like its name says, it's a more direct way to do the same thing. It takes that same, I like this one better data from humans and uses it to tweak the main AI directly. No middleman. So if you look at how they stack up, DPO is just way more elegant. You totally skip that whole step of training a separate reward model, and you don't need the complex reinforcement learning part either. It's a simpler, more stable process that basically just tells the model, hey, make more answers like this preferred one and less like this other one. And this isn't just a small change, it's a game changer. It makes it so much easier and cheaper for more people to build safe, aligned AIs. All right, so problem 1 is alignment. We have ways to handle that, but there's another equally huge problem. An AI's knowledge is basically a snapshot. It's frozen on the day its training finished. It has no idea what happened in the news this morning, let alone what's in your company's latest report. And you can't just retrain the whole model every day, right? That would be unbelievably expensive and slow. So what's the solution when the AI needs access to information that's brand new or even private to you? Well, thankfully, there's a really clever solution called Retrieval Augmented Generation, or RAG. The absolute easiest way to think about RAG is this. You're giving the AI an open book test. Instead of forcing it to memorize everything, you just let it look up the answer in a specific textbook right before it speaks. And the process is beautiful in its simplicity. It works in 3 steps. 1. Retrieve. You ask a question, and the system first searches a knowledge base, like your company's documents, for anything relevant. 2. Augment. It takes the information it found and literally stuffs it into the prompt alongside your original question. 3. Generate. The LLM then gets this souped-up prompt and generates an answer based on the fresh context you just gave it. Simple, but so powerful.
Now, it's really important not to mix this up with fine-tuning. They solve different problems. RAG is all about giving the AI access to facts. Fine-tuning is about changing its behavior, like teaching it to speak like a pirate or write in a specific format. With RAG, you're not performing brain surgery on the AI. You're just handing it some cheat sheets for the test.
Okay, so we need feedback to make these models better, but having humans do it all the time is slow and it costs a lot of money. If you want to iterate and improve these things really, really fast, you need a faster way to grade their performance. So what if you could get an AI to do the grading? And that's the core idea behind a technique called LLM as a judge. You take a super powerful model, like a GPT-4, and you give it one job to be the judge. It scores, ranks, and gives feedback on the answers from other, smaller models. It's literally like having the smartest kid in the class grade everyone else's homework. And the benefits are huge, right? It's lightning fast, you can scale it up massively, and it's way cheaper than paying thousands of human reviewers. But it's not perfect. These AI judges have their own little biases. For example, studies show they can favor answers in a certain position, they often think longer answers are automatically better, and they even tend to give higher scores to AIs from their own family. So while it's a fantastic tool, engineers just need to be smart about using it. So, up to this point, we've been talking about all the things we do to the AI from the outside to shape it. But what's actually going on inside its digital brain? How does it actually think? Let's pull back the final curtain and look at the real secret sauce that makes all of this possible.
That secret sauce has a name: self-attention. And it's the core engine of every modern language model. To put it simply, self-attention lets the model look at an entire sentence and, for every single word, figure out which other words in that same sentence are the most important for understanding its meaning. It's how it builds context.
So how does it work? It uses a clever system called query, key, and value. And honestly, the best way to get it is to think about searching on YouTube. Your search, what you type in the box, is the query. YouTube then looks at all the video titles and descriptions on its platform. Those are the keys. When it finds the best matches, it shows you the actual videos. Those are the values. Self-attention is doing that for every single word in a sentence all at once. Each word sends out a query asking, hey, who here is relevant to me? And then it pays more attention to the words that are the best match.
So when you put it all together, you've got these alignment techniques like DPO, you've got ways to give it new facts with RAG, you can scale evaluation with an AI judge, and it's all powered by this incredible attention mechanism. What you realize is that making a great AI isn't a one-and-done thing. It's this ongoing process of using a whole toolkit of techniques to constantly guide and improve it.
I mean, we've gotten unbelievably good at engineering these systems to follow our instructions, to use facts, and to act just like we want them to. They can imitate reasoning so well, it's almost scary. But it's still an imitation. And that leaves us with a really deep question to think about. As these AIs get better and better at faking it, at what point does the imitation become so good that we can't tell the difference? And if we can't tell the difference, does it even matter?